Hello students, in this video we have two questions of assignment 10.3. Previously we saw 10th and 11th question, that is expression for intensity of resultant wave due to interference of two incoherent waves. Then we saw equation of intensity of resultant wave due to interference of two coherent waves. In this one, we'll derive condition for constructive interference and destructive interference in terms of path difference and phase difference. Okay, so uh, let us start. But before we derive, we'll try to understand that when constructive interference is possible, when destructive interference is possible. Once we understand the physical situation which makes this type of interference possible, then we'll go to maths part, derivation part of the equation. Consider that there is a wave which is heating a particle in this manner, and there is one more wave which is heating particle in similar manner, same particle we are talking about. So let me put the particle here. So what will happen as the two are in same fashion, we may say, or the direction of their influence is same, so the two will add each other's effect, and if the displacement due to first one is a, displacement due to second one is a, then the particle would go down by 2a. Okay, hence intensity of first wave, if it is a square, intensity of second one is a square. Let me label it as I0, I0. The intensity of resultant one is 2a square. It means intensity of resultant one is 4a square, or else I can say it is 4 times I0. That is constructive interference, right? And let us take another situation. What if one wave is reaching a particle like this, and the other wave is reaching the same particle at same time, but in this way? What the poor particle will do? So in this case, these two waves again we are considering identical, so I0 is proportional to a square. What is a? Amplitude of this wave, amplitude of this wave. And the second wave is also having same intensity I0, proportional to a square. Now resultant intensity, if I want to find out, I'll have to subtract the two amplitudes. So a minus a. So resultant intensity will be 0. This is destructive interference. This is constructive interference when the waves are identical. That is what we are going to discuss today. So for constructive interference, the intensity should be 4 times the intensity due to individual wave. For destructive interference, it should be 0. Now, one more thing. Look at this. In this case, the second wave is having 1 lambda less, 1 wave less. And then this condition is possible. Not only that. Suppose if you take one wave, second wave, third wave, fourth wave, fifth wave. Okay, and then in some other case, suppose I have one wave, two waves, three. Now this two will also produce constructive interference. So what is the first wave train including 5 lambda, second wave 3 lambda? What is the difference? 2 lambda. In this case, what is the difference between two wave trains? 1 lambda. Suppose if I have 1, 2, 3, 4, 5, 6, 7. Suppose I have 7 waves in a train, and then 1, 2, 3, 4, 5, 6 lambda in second train. So when you have difference of one wave, look at this, the two will give constructive interference. So in general, I can say that to produce this type of effect, constructive interference, the difference of path between the two waves. This is path of first wave, this is path of second wave. The path difference, if it is 1 lambda, or if it is 2 lambda, or if it is 3 lambda, in general if it is n lambda, then at the end I will get this type of effect, constructive effect. Okay, so for constructive interference, the condition has to be that path difference is integer multiple of wavelength. On the other end, if I want destructive interference, which condition should be satisfied? Let us see. So consider that one wave, say first wave, second wave, third wave, fourth wave, fifth wave. Suppose fifth, and let it be half more. So 5 and half wave I have in first wave train, and then in second wave train, first wave, second wave, third wave, fourth wave, fifth wave, and sixth wave. So 6 lambda if I take. Now look at this condition. The two are producing effect in opposite direction, and hence the resultant intensity will be less. So what is the difference between paths of first and second wave? The difference of path is half lambda. Now this is true for any integer multiple of this half. Okay, so I can say that for destructive interference to take place, for destructive interference to take place, the path difference should be either half lambda, or say it is 3 by 2 lambda, or 5 by 2 lambda, or so on. So in general, I can write it as 2n minus 1 lambda by 2, where n starts from 1, 2, 3, 4, and so on. Okay, so this is the condition for path difference, that it has to be multiple of lambda by 2, odd multiple of lambda by 2, if you want destructive interference. And for constructive interference, it should be n lambda. Now let us go to mathematical derivation for condition of constructive and destructive interference. If we have two sources, say S1 and S2, separated by distance d, and if you consider some point on the screen, say point P, screen is at capital D distance, and let the paths be R1 and R2 from sources S1 and S2, then the intensity equation is given as I is equal to 4I0 cos square K R1 minus R2 or R2 minus R1 makes no difference, because cos is even function. So this is the equation, and what is K? K is 2 pi by lambda, and part difference is many of the times referred as PD, which is R2 minus R1 here. What is I0? I0 is intensity due to simply S1 or only S2. Okay, I is resultant intensity. Now, if I'm talking about the constructive interference, we know that constructive interference is when intensity is maximum. So for constructive interference to take place, I'll have to have cos term maximum, means this cos k r1 minus r2 or r2 minus r1 has to be 1. So when cos theta becomes 1, cos theta is 1 when r2 minus r1 by 2 is either it is 0 or it is 5 or it is 2 pi, I am considering pi because we are going to take square of cos, and then the what we want is plus or minus 1, not only 1. So pi term is okay, and so on. So I can say that if k r2 minus r1 by 2, if it is n pi, or else if k r2 minus r1 is 2n pi with n starting from 0, 1, 2, 3, then the cos theta term will be 1, and then intensity will be I is equal to 4I0. Okay, so this is the condition for constructive interference, but as this is angle, this is called condition in terms of phase. So when phase difference becomes 2n pi, the intensity will become 4I0, that is constructive interference. But if I want part difference, I'll have to make R2 minus R1 subject of formula. So I'll take 2 pi by lambda instead of K. Okay. And now simplify. What is R2 minus R1? So R2 minus R1 now is 2 pi gets cancelled, and it is n lambda. That is what we earlier discussed, that part difference has to be n lambda, integer multiple of wavelength. So this is the condition for constructive interference in terms of path difference. So when path difference becomes n lambda, intensity will become maximum. What is the maximum intensity? 4 times I0, 4 times intensity due to individual wave. In terms of phase difference, this is the condition. In terms of path difference, this is the condition. What about destructive interference? So for destructive interference, the intensity has to be 0. And when intensity will be 0? Intensity will be 0 when cos term becomes 0. So I have to have this value, cos square term 0. So let me compare it with 0. So if cos k r2 minus r1 by 2, if it is 0, then intensity will be 0. Now cos theta will be 0 when theta is either pi by 2 or 3 pi by 2 or 5 by 2, 5 pi by 2, so on. So in general I can say that when k r2 minus r1 by 2, when it becomes equal to 2n minus 1 pi by 2, the cos theta will be 0, and then intensity will be 0. So I can say that k r2 minus r1 must be equal to 2n minus 1 pi for the intensity to be 0. So this is the condition for destructive interference in terms of angle, means in terms of phase. And instead of k, if I take 2 pi by lambda, well, let me mention n here. N is 1, 2, 3, so on. Be careful. N starts from 0, n starts from 1. Okay. Now I replace k with 2 pi by lambda, so I'll have 2 pi by lambda r2 minus r1 is equal to 2n minus 1 pi. Simplify it, and what you will have? R2 minus r1 is 2n minus 1 pi by 2. That is what earlier we did predict, that it has to be odd multiple of pi by 2. Okay, and n is 1, 2, 3, and so on. So this is the condition for destructive interference in terms of path difference. So that is all about this video, conditions for constructive and destructive interference in case of coherent sources. Make sure that you understand this formula and this derivation. It will help you a lot in solving MCQ and even in exam also. Thank you.